Chapter 1.1 Linear Equations and Inequalities. In this section we will review some tools that we're going to use to solve linear equations, inequalities, and applications. Linear equations and inequalities. Students should be able to solve both of these in this section. Students will also be able to apply these concepts towards some application problems. In a first-degree linear equation in one variable, any equation that can be written in the form of ax plus b equals 0 is a linear inequality in standard form. Two equations are equivalent if we set the two linear equations equal to each other in order to yield a solution. We can achieve this by adding and subtracting same quantities from both sides of the equation and by multiplying or dividing by the same non-zero quantity. This will yield a solution to a linear equation. We perform these operations in order to find a solution to a system. Example 1. Solve the quantity x plus 2 divided by 2 minus x divided by 3 equals 5. We can find a solution to this linear equation in a single variable by first multiplying through the entire equation by the LCD, using distributive properties, and adding and subtracting from both sides of the equation yields the solution x equals 24. If the equality symbol is replaced by one of the four symbols, strictly less than, strictly greater than, less than or equal to, or greater than or equal to, the resulting expression is called a first degree or linear inequality. An example of this: 5 less than or equal to the quantity 1 minus 3x times 2 plus x divided by 2 is referred to as a linear inequality. Solve the inequality. 3 times the quantity x minus 1 is less than or equal to 5 times the quantity x plus 2 minus 5. Solving this inequality, we use some of the same properties as we did on linear equations. Distributive property, adding and subtracting same quantities from both sides of the inequality, and then notice in the last step that we divide both sides of the inequality by -2 in order to yield the solution x greater than or equal to -4. When we do this, that is, divide or multiply both sides by a negative number, that reverses the direction of the inequality, and students must pay attention to this special property. Solving word problems. Students should read the problem carefully and introduce a variable. Identify other quantities in the problem and express unknown quantities in terms of the variable you introduced in step 1. Write a verbal statement using the conditions stated in the problem, and then write an equivalent mathematical statement, equation, or inequality as the case may be. Solve the equation by using the steps that we have covered in the first part of this section. Check that solution, make sure that it satisfies the original problem. Example 1, an applied problem involving break-even point. A recording company produces a compact disc. We'll call them CDs. One-time fixed costs for a particular CD are $24,000, and this includes recording, album design, and promotion. Variable costs amount to $6.20 per CD and include manufacturing, distribution, and royalty costs for each disc actually manufactured and sold to a retailer. The CD is sold to retail outlets at $8.70 each. How many CDs must be manufactured and sold in order for the company to break even? This first example, break-even point, we will let X be the number of CDs both manufactured and sold. fixed cost of $24,000 and variable costs of $6.20 per X number of CDs. Therefore, the cost equation for this is $24,000 fixed cost plus $6.20 times X, the variable costs. R is the revenue on sales generated by X number of CDs, and that's equal to 8.70 times X. The break-even problem results in setting R equals C, that is, revenue equals costs, and we can see that 8.70x is equal to 24,000 plus 6.20x. Using the properties that we developed in 1.1, we both add and subtract from both sides of the linear equations and then divide through by 2.5 in order to yield a solution of 9,600. So therefore the company must make and sell 9,600 CDs in order to break even. If we check this into our original equations, we see that that yields both $83,520 for both cost and revenue.